we will talk a little bit about gaming across multiple devices and what Microsoft do as a platform manufacturer to bring you tools to build up on our technology stack, and likewise cloud services to scale applications with a bigger and growing market and with a lot of people using your applications. Tom.
Yeah.
Maybe you introduce yourself a little bit.
Should we introduce each other?
Yeah.
Maybe
before that would be nice.
Yeah, great. So let's start with Patrick.
Okay.
Patrick is developer evangelist at Microsoft, which means Wanderprediger, Mist. A guy who walks around and speaks about developer tools, about Visual Studio, about .NET, and Azure is one of the tools for you.
Absolutely. So Tom is one of my colleagues who focus on games, game development. He is one of the founders of Anthony, as well as a few other game projects he did in the past few years to support and bring to market, which is very cool. He works a lot with students and startup companies to bring their ideas to life, which is very, very cool.
Great.
Okay.
So, first of all, our topic, come to the dark side. We all know that, Azure, Microsoft is not the first company you think about when you start to think about cloud. We know that. But now we have cookies. So grab one and take a seat and see what we can talk about. So.
Absolutely. So what we wanted to talk about is a little bit about the cloud, about HTML5, which is a huge trend now in the market. So from our perspective. And as well as devices, which is also one of the main things when we think about consumerization of IT. Okay, so this is a funny one. I'm not quite sure. In Germany, how many Germans do we have here? Almost everyone. Okay, there's this 7 seal thing going on. Nobody knows what it is. In English, it's called closed book, which is not that funny, but okay. We try to say here that Windows Azure is a huge product, and we wanted to make it a little bit visible to you what we're doing and what you can do with this platform and why we think this is a good platform for you. We start off when you come to server-side solutions by on-premise solutions. So you do everything. You host the server, you buy the hardware, you do all the necessary stuff to get started, which means you even plug in the cables. On infrastructure as a service, you don't have to do that stuff. You can just run with your application. You don't have to care about the operating system, about the hardware. You rent them, and then you bring the application, you bring software, runtime, all that kind of stuff. So a lot of maintenance, as well as you have to do the sysadmin stuff, which we think, from our perspective, is what we can do for you. We're not good in it when it comes to Linux, but we're good in Windows. We know how Windows works because we build it, and so we think we can automate that process for you. And this is what we say with platform as a service is a good solution. So we do anything for you in order to get started. The only thing you have to care about is your application. So this is where Windows Azure is mainly focused on, with platform as a service. And then we have software as a service, and you all know it, you all use it, like Gmail, like, I don't know, Bing, maybe not, maybe Google, but maybe other services from us, like Hotmail, like other stuff. This is software as a service. So what is Windows Azure? Well, interesting question. It's
a big thing.
A big thing, a very huge thing. It's sort of a good mix of products and things which help you to be successful in the cloud, I would say. Developer resources?
Yeah, that's what you need to develop for the cloud. We bring the services, which means the compute power, the storages, whatever. We will show that in the next slide. But we also bring the tools for it. So with Visual Studio, with the MSDN, with all the resources we bring, we can develop very fast and efficient.
So one thing I want to mention here is not that you have to use our platform tools like Visual Studio, or you have to use C#, .NET, whatever. You also can use Eclipse, you can use PHP, you can use Java, whatever runs on Windows, you can use it. Like Node.js, we ported it actually a few weeks ago. We released the first stable version of Node.js. Turns out it works very, very well on Windows. We did a lot of stuff to support Node.js in this topic. So if you're interested in your beloved development platform, you don't have to change that in order to use the cloud services. Okay, so but we start with some development platform, and we have the cloud services like we have a compute engine where you can have virtual machines in, we have databases, sure, we have sort of messaging system underlying it, we show it a little bit later in the talk, and we have identifying and caching, and what it makes easier. So what you do is you deploy your application to the cloud, and you do that by plugins in your development tools, which means you can use Xcode, you can use Visual Studio, you can use Eclipse, and we have plugins for those. And then you just simply deploy your application. This is one scenario. A typically other scenario you can use is you have a local application, like, I don't know, you have a game which has a backend somewhere in the cloud, and massive multiplayer game, for example, and you wanted to communicate. So you can also use that services you deployed from a local client, or you can use the Azure services directly from your local client if you want to. So we talked about devices.
Yeah. So what's the idea about it? To port all the calculation power into the cloud brings totally new possibilities for the client. So we draw here a set of common known devices like the Windows Phone, which is very successful, by the way.
Which no one had guessed 2 months ago, but...
Yeah, thank you to Nokia.
Thank you, Nokia.
We have the iPhone, we have the iPad, all the mobile devices.
Android.
Of course.
Which is the market leader,
how can
right?
I forget the Android?
Don't forget Google.
Which have very low calculation power comparable to a normal computer. You try to port everything to the cloud. This have two good reasons. First is the calculation power. The cloud have much more calculation power than the device. And the other thing is?
You have one business logic somewhere in the cloud. You don't have to program it on different platforms, which means if you look to Android, you do it in Java, which is fair enough. Then you have Objective-C on iOS, which is a little bit of pain, but hey, it's the iPhone and you want to be on that market. And then we have Windows Phone, which is Silverlight, which is another technology. So you have to have developers who can speak 3 languages at least. And it's sometimes hard to find those people, but it's doable, definitely. But it's easier for you if you use one platform, bring the logic right there, use the cloud as backend, and then be available on all the devices and just build the user interface. So, dude, wait, what?
What?
Okay, so we talk a little bit about hardware, because other platform manufacturers or other platform offers from the cloud are typically based on hardware. So we want to spend just a few minutes on hardware. No, Marty here doesn't like that talk, but doesn't like to talk about hardware. So this is one of our data centers in Dublin, which we have 2 in Europe. One is in Dublin, one is in Amsterdam. All over the world, we have 6 of those data centers. This is a 500 million invest we did, and the main idea behind it is that we wanted to be different this time and try to work on hardware, not from a typical perspective. So when you go to a data center, you have your 80 degrees, everything is cold, the system is running smooth, everything works fine. What we tried in the past years is heating that systems up, because we found out that the most invest we do is in cooling the systems. And actually, you don't need to cool all the systems, because CPU doesn't care if it's 50 degrees or whatever. As well as memory, it doesn't care about the degrees. The only thing really cares about degrees is storage. It's your hard drive. This is a physical thing we have a problem with. So what we built is this storage rooms behind the collocations, we call them, which is a server rack. So this is this little room behind them. And what it does, it just takes the heat of the computer and brings it back to the environment, which is a very complicated thing.
This is, by the way, a stupid diagram.
Yeah, it's a stupid diagram, but I think this is better. So Microsoft reinvented the way how, I have no idea what, chimney? I have no idea how this is called, but you can get the idea. So we reinvented that, and we call it since then Fabric. So we call our data centers Fabric. Because we have pollution.
No.
So in the European Union, for the first time, every time you read Microsoft in the European Union, it's like we pay the European Union. This time we get a prize for it, because we have this thing going on with the power usage efficiency of data centers. And for the first time in history, we get to the point where we had 1.25, which is a pretty good factor to work on, but we still want to be more and do it better way. Because if you look into data centers right now, what you see is IT equipment at 50%. You can get rid of that cost, right? But what you can do is things like light, things like power supply, cooling. Those are costs you can even try to do a little bit more on it. So we came up with containers, which are very flexible because you can put them in the desert, give them a cable, and everything's fine. So that is the primary idea of it, right? You can place them everywhere you want. If you have a Super Bowl or you have a football or a soccer game somewhere, you want to stream data, or you have a big online game somewhere and you need more traffic somehow, you can get one of these and just put it there. And again, we build a data center which works the way Dublin works. We put the containers, have the store rooms, and bring the heat away from the system. And then we built up those containers back in 2009, which were prototypes built up in 3 months, which are small data centers. So this is the actual stand. They have everything you need in order to be productive. eBay bought a few of them in order to build their iPad shop, which works very well. Both the store and the container.
And the iPad.
And what the primary idea of it is, so we go back to Windows Vista, which I know a lot of people don't like, but this was the first time we brought hypervisor in the game. And hypervisor is a very cool thing because hypervisor abstracts the way how we interact with hardware. So a few years ago, when your graphic card gets an error thrown, you get a blue screen, that's it. You're out of game. Meanwhile, you have a good chance that Windows says currently not responding for a few seconds. It refreshes, it restarts the graphic card, and then you can move on. This works 50-50. So you have 50% chance that it works. But on the other hand, operating systems have to do other stuff like memory management, process management, those kind of stuff. And we do all of that on top of hypervisor, which enables us to do the following. On the server side, we also have the hypervisor, and we have the same operating system features, but we can bring another middle layer on top of it, where you can host your virtual machines. So this feature is called Hyper-V Server, and you can have multiple VMs running there, at least 8 on one CPU. When it comes to Windows Azure, what we did in Dublin is we built those columns, and on top of it, over the whole data center, we built up the hypervisor. And we built another middle layer, which is called the Windows Azure Operating System, which runs on top of hypervisor over the client, over the systems. And we have the Fabric controller. We explained why it's called Fabric, and so we had a software which is the Fabric controller, which gives us the possibility to say, hey, this server needs more power, this server needs more traffic, this server needs that, so we can scale the system up automatically. And so what you get is the possibility to bring a virtual machine in. And a lot of people ask us, seriously, that's all? Yeah, that's all. So what we have here is the Windows Azure portal where you can manage your virtual machines, and we can connect to that computer, I guess. Here. So we just go and do a remote desktop connection to that server, say, okay, connect. I have to remember the password. Ta-da. Is this sign good for us?
Well,
at least we try.
Hey,
yeah. So, and what you get is just a simple Windows server. And what you can do with it is you can configure it, you can install all the stuff you want, but still, it's just a Windows server in the cloud. There's one thing about those virtual machines, they're not persistent, which means from time to time we do reboot, we do the security patching for you, we take care of the Windows as it's being, so you don't have to care about it. Think about it. You don't have to care about antivirus. You don't have to care about all this kind of stuff.
And about licenses.
And about licenses.
Because we install it every 30 days again, and it's the test version,
yeah.
right?
This copy is Windows is not genius. Yeah, that's why we are so cheap, right? It's fair enough. Okay, so it's just a Windows server, and I just wanted to show it to you. So really, seriously, it's nothing more than a Windows server. So remote desktop, but back to your app. There's more to an application than a backend and a Windows server and hardware, what you need. And so there are typically free instances of virtual machines we bring you out of the box. You don't have to configure them. So that's the cool point. So you don't have to install something, you don't have to install Windows. We just bring you those free instances, you can go for it. One of them is the web role, which means everything which runs on top of an infinite information server, which is PHP, ASP.NET, ASP.NET MVC, Ruby, Python, and as well as Node.js. You can run it on a web role. Then we have the worker role, which means it's like a Windows process. You can program like a little program which listens to some traffic, repeats something, do calculations, do mathematics. I don't know. It's just a Windows service. Like,
well, actually, it's a process. Just start it, do whatever you want, and do it in a while loop.
So
that's it.
Fair enough. Yeah.
Open ports, do whatever you want.
Then we have the VM role, which is a virtual machine you can configure by yourself, upload to the cloud. That's primarily the idea of the VM role. So you more flexibility. Okay. So when I want to get started with a cloud app, the only thing I have to do is I just go to Visual Studio in my case, or Eclipse if you like it, and say new project. And then you get those templates. You get them as well in other programming environments. You say new cloud. And then you can choose from one of those pre-installed templates. Since we're talking about HTML5, we use this one.
So we support HTML5?
Yeah. And it's pretty simple. It's just you have to check it here.
Oh, it's that easy.
It's that easy.
Okay.
That is HTML5. You believe me, right? Okay.
So actually what happens, Visual Studio creates us the necessary projects, which is the same like a local installation of an IIS project.
Yeah.
So this one is just a web project, like I use it for a local IIS. And after that, I just put it in the Azure project as a role, and after that, it's a cloud project.
Exactly. So you can configure all the Azure necessary stuff right here. We have the property window where you can just say things like, no, you can't. You have to use that. Sorry. You can do something like choose the VM size, which could be small or extra large. Extra large means you have 8 CPU cores, which your virtual machine can use, or 1, which is small. We have also a few other instances upcoming in the next few months, but this is the actual way how it works right now. So you can define endpoints like HTTP. So it's very, very simple to do that. You also can say you have some connection strings, you can put them here. You can work with storages, or the kind of stuff can be configured right out of there. But I think we just run it. And while most of web developers work with a local Tomcat or work with some other or work with some other local resources, you have to start at Visual Studio as administrator. So that is the problem here. Which is a typical error the presenter does. So you work with Tomcat, or you work with sort of other local development machine. I don't know. We call our developing machine Cassini for the past few years, and it turns out Cassini cannot simulate SSL, so we brought IIS Developer Express, which can also simulate SSL for you. But in order to test the cloud locally, what we did, we built some emulators. And we built those emulators for different platforms, so you can use them to work against the cloud without going to the cloud and working there. So you can develop and have a seamlessly interaction with the cloud on your local device. So you don't have to pay while you develop.
Yeah.
Way.
More error messages.
More error messages.
Please ignore. Oh, that was the important one. Do we really need to show that?
And we can show the emulator here.
Yeah, that's what we can do. Actually not.
Okay. Good, but so you get pretty much an idea. I have no idea why it's not working, but it should.
Yeah, who cares? So
yeah.
Under normal circumstances, it works fine.
It would work fine. Okay. So one of the things we learned from our partners and customers is when it comes to the cloud or to projects in the cloud, it's not about availability. Availability is something which you get when you come to the point where you think about scaling. So if you do things in software design in order to scale, to be a successful web application, to be a successful backend for your game, you do things like splitting data into chunks and bring them somewhere into storages or somewhere else. And availability is not something you focus on. It's not something you can design a software to be available. You can design a software to scale. You can design a software to perform. What you get is availability. If you have a software which is more scalable, then you get availability for free. But it's not like you focus on availability. So the real question is, how does my app scale? And we wanted to give you just a few tips and tricks on what you can do in order to scale your application. So first of all, there is no place like home, which means there's no place like production. You can test, you can write unit tests, you can do a lot of stuff. You can have multiple users testing your account. But the first time your system gets hit by the 10,000 of users at the same time, there is no test who can do that for you. Even the best unit test will fail in that thing. So you will have to deal with different circumstances. So the next few points we show you will help you in order to achieve that. So this is lessons learned by our customers and partners. And the cool thing about us and from our perspective is, this is the real benefit we can bring you, is that we design technology in order to help you get rid of those problems, like table storages, like caching, and those kind of stuff. And we show them right now. So scaling, there are two types of scaling here. One thing is what you all know. Hey, if I have a computer and I need more RAM, then I just buy more memory, I put it into the computer, I plug it in, and everything is fine. So we call this thing horizontal scale, so you bring up more power. Then the vertical scale thing, which the cloud is known for, is you run more instances of it. So in order to have one machine doing your calculations, you have two machines doing your calculations, or 3 or 4, or how many you need. Yeah, we skipped the. We have databases in the cloud. Thank you. Okay.
Okay. Good. Let's take a look on some of the showcases.
Yeah, absolutely.
Because this is the more interesting thing. So the relation to gaming. You can do it on different ways. Our first showcase is RaidGate, which is basically a community platform to organize your raids in World of Warcraft or something like that. It's a simple website, but it's hosted on Azure. It's hosted on the cloud, and so it's scalable. So it's not a big issue with different storages or different tasks. It's just a website. That's the simplest way to use the cloud.
But it's still necessary. I mean, if you look at things like Ventrilo, how people organize in order to play games in the cloud, in the web or online games, then they use this thing to organize themselves. They use this thing to organize their state-of-the-art their games and their social behavior. I don't know how to explain that, but you have times where you have more users, like 10,000 of users, and you have times where you just have 1 or 2 users. When you just have 1 or 2 users, you don't need 20,000 servers. But when you have 10,000 users, then you just have to have 2 or 3 servers more. So scalability also means, from our perspective, that you can every time scale automatically, compute power up and down. So you pay only for the users who really use your application.
The next one is a very special one. It's AndMe. Who of you knows the AndMe project? Oh, only two people. Thank you. So Enemy is basically a client application. It's a client game. You as a player should learn programming skills. So basically you program an AI for a small ant, and the ant needs to survive in the real game, in the simulation, the real world. Needs to collect food, needs to collect sugar. Sugar is food too.
Yeah.
Fight against bugs or fight against other ants. Well, normally you play that locally. So it's not very funny because you play against points. It's not very cool. We built a platform which makes you able to play against others. So there is a world leaderboard. How should I name that? Yeah, and league
system.
Yeah, and you have the chance to play against other players. Sorry. The architecture behind that is a little bit more complicated because we need a lot of storages, we need a lot of communication between the tasks, and therefore we use that different kind of storages. There is not only a database behind, not the SQL server. It's more specialized storages to share information between all the tasks which runs. Would you say something to the sources, or should I just say that?
Tables, I just wanted to point out, well, tables is something you have to think of like Excel sheets, which are not known for their relational bindings and whatever, but they are extremely fast. So that's the point. They are extremely fast, faster than every SQL server could ever be. So if you need data fast, you use the table, you don't use SQL Server. And it's cheaper. Then you have the queues, which are just you pull something in and you get the latest item you put in first. So this is just a queue where communication could happen. So Tom mentioned that he have to simulate a lot of stuff. In order to have machines simulating at the same time different games, what you do is you use a queue and just put in a game, and then a lot of computers can grab that and can calculate on that. So queue is a very, very good way to implement that way. And blobs still, if you have videos, images, big data, whatever, store it right there, because this is a serious good place for it to have a persistent blob storages, because all of this we save 3 times. So we hope that's enough. We hope it's enough.
Yeah. Short view to the architecture. It's very easy. So at the left upper corner there's the player who uses the website, which runs on a different server. For now it's a root server, not hosted in Azure, but works fine together. User can upload his ant in form of a file. Yeah. This will be stored in a SQL server, which is in the backend. And after that, there is the whole Azure constellation, which grabs all the outstanding matches and queues them in one of the queue lines. And in the right lower corner, the simulation stack, there are n numbers of instances of simulators, which grabs that matches, simulate everything, stores the reply file on the blob storage, and gives the information to the user. That's what happens in the backend. Okay.
Fair enough. Tom, you ported it to Windows Azure.
Oh, sorry.
So from your perspective, what was the hardest thing to do and what was the easiest thing to do?
The hardest thing was to
compare it to an on-premise solution from your perspective.
Well, the on-premise version works totally different, so that's not the question. But the hardest thing was to think about the scalability, to think about parallel processes, which works independent to each other. That's it. If you can separate all your tasks in your application, in your game, wherever, you just can separate them to different worker roles, and then they can work independently. Okay. That's the hard thing.
Cool.
All right. We have the fourth showcase, which is the Saudo app, which demonstrates that stuff here, the stateless idea, which means if you scale in a lot of instances, you need to be stateless.
It's what they tell you, right? I mean, but one question from our point is, have you ever seen an online store which is stateless? I mean, hey, I have a shopping cart. I put something in the shopping cart, and that's a state from my perspective. So yeah, sure, I can call it every time with my user ID. User XYZ stores that information. And sure, this is what others do. This is what eBay does. This is what Amazon does for all the years. It works pretty well. But for small shops, for small shop systems, it would be fine if we could have the same state on different machines. So what we see here is the user calls for the first time and does something, I want to buy that, and it's in instance 1. And the second time it makes a call to another, he points to another server. And you cannot manipulate that, what is happening in the load balancer. Because the load balancer is looking, hey, this server is doing a great job, this server is busy, so why don't we go to that server? And so you probably, with the second call, you land to the instance 2, and you have a totally different state in your shopping cart because the information stored before was in another server, but another instance of a server. So in order to get rid of that problem, what we did is we built up a system which is called Windows Azure Caching, and that helps you to not only store your information in memory, but to store it into a cache where each and every machine can work against that cache. So it's just in the middle layer which helps you seriously and supports you by developing stateful applications. So you don't have to be stateless anymore.
Especially for the session handling.
Yeah, extremely important.
So the cache is used for standard session handling from the IIS, which means you have the same state on every instance of your web role, which is very important if you don't want to care about it.
So don't care about sessions, we do that for you.
Great. The last example for a good cloud computing is Fantasy Kingdoms. It's a Facebook game. It's written in Flash, so the client is written in Flash, but the backend is an Azure application. And this is a very common scenario in the casual or social gaming area. The communication works with the classic web services, so it's asynchronous play, and yeah, it works very well. So if you want to try it, it's a very famous Facebook game. All right, Saudo's app. Yep. So if you really want to see a very basic app, how can communication work together with different clients, come to the booth, because we have no time anymore. Yep. But a short view on the communication concept looks like that. So we bought a small application which runs on the web. It's basically a web application, but we also have some web services which are available for all the devices. We started with a Windows Phone application, of course. Yeah, and we use the VCF concept, which is a very common concept in the .NET area, to communicate between them. But it's also possible to use, of course, OData, or it's possible to use sockets with very easy tooling.
JSON for the iOS.
Yeah, and if you want to port everything to the others, let's say, you can, of course, do a HTML application, which runs in a browser, but you also can use the CDN, and you can use the JSON-based communication interfaces to get all your information to the client. And of course, sockets. Of course, you can sockets. Yeah. So that's basically it.
Yep.
We
have CDNs.
Okay, that's enough.
We have CDNs, 24 of them, working fine, working smooth. We have some tips and tricks for you. If you consider going to a CDN, check out our blogs. There's more information on that.
Blah, blah. And we have security.
We have security, yeah.
Okay, so now let's come to the point.
Yep.
Why should you use Microsoft?
That's a good question.
That's a very good question.
Absolutely.
So we are not very famous in the gaming area, I know, but we have big experience in the enterprise market. And the enterprise really needs scalability, needs stable applications, and for some reasons, I don't know, security. should be also very cool. And this becomes more and more interesting in the gaming area. And we are good in it, believe us.
And we also have certificates for security. So in Germany, if you want to be a provider for services, or in Europe, you have to have this data contract. We can guarantee you with a certificate that our data centers are safe. So the only thing you have to prove is that your application is safe and you have a security service. Yeah,
and don't forget all the resources. MSDN is a very good place for getting information about our API. We have a good support. Absolutely. We have good technical resources, and the most important thing on that list is the BizSpark program. if you are a startup, not older than 5 years and a limit of, I don't know.
$1 million, I guess.
Yeah, okay.
Something like that.
We have special support for you, which means free software and free consumption time on Azure, which means very easy to start with. No costs and no cost for tools.
Yeah, so everything is for free.
Yep.
That's the message. If you're a startup, this stuff is for free. Why don't you check it out?
Great.
Yeah.
So go to windowsazure.com, and if you don't find the answer, go to our blogs, blah, 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 write us an email. Oh man, how many slides are there?
We have a lot of them. We are in the booth, so come and ask us some questions, as well as our friends from Exit Games, and we try to be on GDZ to have more stuff for you coming, and cool examples where you can look at. And so, yeah, we're open for questions.
So we have a question?
Actually, we haven't time for question and answer. So thank you very much for your session. If you want to have if you want to ask the questions, you can come to the booth of Tom and Patric and ask personally.
Yep.
So thank you very much.